coterminal angles, increasing or decreasing the degree measure of an angle in standard position by an integer multiple of 360 degrees results in a coterminal angle. So theta is equal to plus or minus 360 degrees times k, where k is an integer. So what does that mean? Well, if you have a 410 degree angle, let's look at our unit circle again. You're going to start here, 410 degrees. First do one full rotation, that's 360 degrees, then figure out what's left. So that's why I'm subtracting 360 from 410 to get 50 degrees. If you're starting with a negative degree, because it's a clockwise turn, just add 360 and you will get the equivalent measure. You can also do this in terms of radians by adding or subtracting 2 pi. So if you have a positive angle, you're going to want to subtract 2 pi. So you're going to need to get a common denominator. So multiply top and bottom by 5, and that will be 10 pi over 5. And then when I subtract the 13 and the 10, I get 3 pi over 5. So remember to get your common denominator. If I start with a negative angle, clockwise, I'm going to want to add 2 pi. Once again, get that common denominator, multiply top and bottom by the denominator 15, negative 1 plus 30, 29 pi over 15. Find a positive angle less than 360 degrees or 2 pi that is coterminal with each of the following. So if you are in degrees, you are going to continue to subtract 360 degrees for a full revolution until you can no longer do so. What's left is your coterminal angle. 17.4 angle, notice I didn't put a degree, that means I'm in radians. So you can subtract 2 pi, or you can use 6.28, which is the equivalent of 2 times 3.14 for pi. So I do that, and then I get 4.84 radians. 17 pi over 3 angle, because this is in pi, I'm going to use pi. Subtract 2 pi, which, getting a common denominator, is 6 pi over 3. So I'm going to do that once, but I'm still going to be able to keep going because of how big of an angle this is. So you keep subtracting 2 pi until you get the smallest thing you can get before you go into the negative numbers. So it's 5 pi over 3. But if you have a negative angle and it's in radians, you want to add 2 pi. So I'm going to add 2 pi, which is, with a common denominator, is 12 pi over 6. I keep adding it and adding it and adding it as many times as I can. 11 pi over 6. All right, a circle has a radius of 6 inches. Find the length of the arc intercepted by a central angle of 45 degrees. The arc length is equal to the radius times theta, where theta is in radians. So we've got radius of 6. We've got 45 degrees, which you can convert to pi over 4 radians. 6/4 reduces to 3/2. And then you can go ahead and multiply 3 times 3.14 divided by 2 to get 4.71. Definitions of linear speed and angular speed. So V equals S over T, omega equals theta over T. Linear speed in terms of angular speed, and this is all in your book, V equals R times omega, where omega is the angular speed, and R is the distance from the center of rotation. So in other words, the radius. So linear speed is the radius times the angular speed. So on this last problem, you're going to take 1.5 inches, that's your radius or your R, and you're going to use 45 revolutions per minute, but you're going to need to convert that angular speed needs to be converted to radians per minute, and right now it's in revolutions per minute. So we know that 1 revolution is 2 pi radians, so this will cancel this, multiply by 2 pi, so I'm multiplying 1.5 times 45 times 2 pi, and then multiply 3.14 times 135, and I get 424 inches per minute.